In this video, I want to prove by mathematical induction that the statement you're having here is equal to the right hand side is true for integers n. But the first thing I want to do is to simplify this statement here. The statement you're seeing that has this sigma notation or summation notation. I want to simplify this statement. So how am I going to do this? The following steps must be considered in order for you to be able to simplify this. I want to show you how you can represent this one. Of course, if you check the previous videos of induction, you did not see anything like sigma sign, and you having it like this thing has meaning. Let me show you the interpretation of this so that you can be able to understand it fully. So let's start with solution. So from the left hand side, I'm working on the left hand side, which is this one. This is called right hand side. This statement means j starting from 1 and tends to n. What does it mean, j starting from 1 and 10 to n? This is what it means. It means that we'll be having 1, 2, or we can use 1 plus 2 plus 3 plus, that is starting from 1 up to n. N meaning that we don't have a particular term this should advance to. So maybe I can have 1 plus 2 plus 3 plus 4 plus 5. That's the meaning of these summations, sigma. So, but then because it is to infinity, we just put up to the number n you're having. So this statement is the same thing with this one you're having here. So as if that was not enough, when we have j to be equal to 1, that is this j to be equal to 1, it simply means that cj, which is this cj you're having, is equal to c multiplies by 1. Notice that the j is equal to 1. And what will be the result to this is c. Of course, we can also check for when j is equal to 2. That means cj will equal to c times 2. And this will give you 2c. And then we need to check also for when j is equal to 3. And we have cj to be equal to c times 3. And this will give 3c. We can also check for when j is up to n, or is equal to n, then we have cj to be equal to c times n, and this will give us cn. Alright, so considering the left hand side we have already of this given statement, then this implies that this statement, this sigma notation, which has j equal to 1 up to n of cj will be equal to, we have c plus, what is the next one, 2c. I'm saying that this left hand side means 2c plus 3c plus cn. Alright, so therefore in place of this whole one or whole expression you're seeing, we could just represent this to be c plus 2c plus 3c plus dot dot dot, that's to infinity, plus c, and then if you want you can use k, but in this case we just want to maintain the n, we're using cn. Alright, and this will be equal to the right hand side. What is the right hand side? That is c n into n plus 1 all over 2. I hope this is clear. You can see that we have reduced this statement from this point to this particular point. Right? So what is the next thing we need to do? We need to follow up the step 1 that we have been using in the previous videos. If you've not watched any of the videos on principles of mathematical induction, don't worry. I'm going to drop in the description of this video the link to those videos so that you can be able to get broad knowledge of it. So the first one is that we need to let this above statement be p of n, or if you want to make it more simpler, you just say putting That's step 1. Putting n equal to 1 in this statement above. Of course, if you put n equal to 1, it means that the left hand side, I want to use another pattern of solving. The left hand side, instead of rewriting everything, will be equal to, what is the left hand side? This one. So we have c into 1, and this will automatically give us c. That's for the left hand side. What about the right hand side? Right hand side, which is this one, we have c into 1 into 1 plus 1. That means anywhere you see n, you just put 1, because we say putting n equal to 1. In other videos we say show that n equal to 1 is true. So that's the same thing. So this is equal to, or divide by 2. 1 plus 1 is 2, and 2 times 1 is 2. 2 times c is 2c. Divide by these 2. Of course, you know that this will cancel out. So what you have is c. So since you notice that the left hand side is equal to the right hand side, it means that n equal to 1 is true for all natural integers. You can just say thus p of 1, or you can say n equal to 1, or you say n equal to 1 is true for some integers, or some natural integers or numbers, right? N. Okay, so having satisfied this first step, of course you know how we go about this system. Looking at this expression carefully, it means that you will need to follow up the second step. And what do we need to do at the second step is to make some sort of assumption. So we have step 2. In the case of step 2, we always assume p of k. It looks like I usually use n equal to k. That's the method I always use, but the same thing as this p of k formation. So we want to assume that p of k, or n equal to k, is true for some natural number. So that means from that expression we have c plus 2c plus 3c plus dot 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 plus, in place of this n, we replace it with k. Remember we say when n equal to k, so we have ck. This will be equal to, what about the right hand side? It's the same thing you need to do. Look at the original question. Anywhere you see n there, you plot in k. So we have c into k, or multiply by k, into k plus 1 all over 2. So this is essentially what you need to do at the left hand side. Alright, so when you're done with this, it means that we need to make some sort of conclusion. P of k is true for all integers of n. Alright, so the next thing we want to do now is to go straight to the next step, which is step 3. And of course, you know how we go about the step 3. It's very simple. Look at how I'm going to break it down again. So in step 3, we're going to make some, from the assumption we had made above on the step 2, we're going to show that, or deduce. Let me fix this camera. We're going to deduce that p of k plus 1, that is, what I mean is n equal to k plus 1, is true. Alright, so the above statement means that the expression ck that we had on this other point, this expression ck on the left hand side of this P of k, what needs to be done there is that it has to be increased by 1. This ck will be increased by 1. That's the meaning of this k plus 1. You know, of course, here we have P of k, and then we come to this point ck. But this time, this ck will be increased by 1. So how is it going to increase by 1? It's simple. So you have to copy the step 2. We had c plus 2c plus 3c plus up to the number c of k. And what did I say about this? This will have to increase plus, this time our k now will increase to k plus 1, all right, which is equal to, then what do we have at the right hand side? From the original question, you will notice that we will just substitute anywhere you see k, replace it with k plus 1. So here we have c into k plus 1 into k plus 1 plus 1 all over 2. Look at it. Anywhere you see k, just increase it to k plus 1. That's the meaning of this when n is equal to k plus 1. Of course, if you check on step 2, the original question, you will notice that, look at it, n is, in place of this n, you just replace it with k plus 1, replace it with k plus 1. Already there is 1 in that question. So what do we need to do at this point? We will just have to make sure that in place of, from this point c down to this point, it is what we have on step 2. Look at it, from this point to this point, ck gave us the whole of this. So we have to replace this with this expression. So here we'll be having ck into k plus 1 all over 2. That is for this. And then plus what we have here, c into k plus 1 equal to, here we have c into k plus 1 into k plus 2, because 1 plus 1 is 2. This should be over 2. So what do we need to do here? We are having the base 2 here, the denominator 2 on the left hand side. We have 2. Here we have 2. We can as well make here to be 2. And if you make here over 2, you must add 2 here, because 2 divided by 2 will be 1. It will now go back to the same point. But if you don't understand that, let's use this other method. You can make it over 1 so that it appears like fraction. This is a fraction. Numerator, denominator, numerator, denominator. So make this one to look like fraction. After all, this divided by 1 is still the same thing. So that from the, leave this right hand side, just work on this left hand side. So look for the LCM of 2 and 1, which is 2. 2 divided by 2 is 1. 1 times ck is ck into k plus 1 plus 1 into 2 is 2, and 2 times the whole of this is 2c into k plus 1. Okay, this was what I was essentially telling us, that you can make here 2 over 2, because this 2 can also be for this man. But since we have chosen this method, let's proceed with it. This remains c into k plus 1 into k plus 2 all divided by 2. Now, I don't like the position of this 2. Let's remove this 2. How can we remove? You can multiply both sides of the equation by 2. If you multiply both sides of the equation by 2, this 2 can cancel out with this 2, and this 2 can cancel out with this 2. But even if you don't want to multiply both sides by 2 to remove the 2, you can still solve with the 2 available. It's not going to be an issue. Alright, we have different methods to work on this, but what we want to do is to make sure that the left hand side is the same thing with the right hand side. So let's further simplify this. You can see that k plus 1, they are common. So I'll just pick one of the k plus 1 because they are common. And then what is remaining? I'm having ck plus 2c. Is that true? Yeah, 2c. Remember, this k plus 1, they are common, so I just factor out this. This times this will give us back this, and this times this will give us back this. And this is equal to what we have at the right hand side, which is k+1 into k+2. So finally, you check on this particular bracket, you notice that c is common. So we can decide to put that c outside, or if you want to put it here, it's still okay for better understanding. C is common, so I'll bring that c out. So what will be remaining here when you remove c is k. What will be remaining when you remove c is 2. And this is also equal to c into k+1 into k+2. And then finally, just place this c outside to start up the system, and then put k+1 into k+2. And this is exactly what you're having on this other part, k+2. You can see that this left hand side, since the left hand side is equal to the right hand side, then n equal to k+1 is true for all natural integers n. So this is the final point of this particular question, and I'm sure you enjoyed this video. I'm very sure you enjoyed it, and if you know you enjoyed it, please hit the subscribe button. That is if you've not subscribed before, but if you subscribe, I really appreciate you, my returning subscribers, for watching my videos. Thank you very much. You are the one that is making this video grow by your likes, your sharing, your subscription, turning on the notification bell, and always following up when I post a new video. You've been an amazing person, so thank you very much for always coming through. And then I will also do much problems on this PMI, technical problems. So make sure you turn on the notification bell after subscribing, like this video, and make sure you drop a nice comment if you really enjoyed this video. I really do appreciate that if you found this video helpful. Thank you, and I will see you on the next video. Bye.